Hello everyone, my name is Jupitris and today I'm going to show you how to build a single layer perceptron. I'm going to be using the Collab Research Google because you don't need to install anything. You can just use the library. So it's good and it looked like just like Jupyter Notebook. So yeah, just let's get started. The first thing we need to do is we need to import some library. So let's do it. So the first library is pandas, and then we need numpy. We also need train test split to split our dataset. So from scalar, then we need a scalar. So I'm going to use min max scalar. We need to import some metrics like confusion matrix and accuracy score to see how well our our machine learning model is. So yeah, let's do it. Hold on. Scalar. Okay. Oh god. Okay, since I'm going to be loading the dataset from my Google Drive, so we need to import the drive library from Google Colab. So it's from google.colab for drive. And now to actually mount the drive, we need to drive.mount single quote and content slash G drive. Okay, and run this. Okay, it's already mounted. Okay, cool. So let's create another cell here. Okay, so we need to load the dataset with pandas, obviously. Let's see if the dataset is loaded. My drive. Okay, nice. Okay. Next, we need to see if there is any duplicated data in our dataset. So we can dataset dot duplicated. False, blah, blah, blah. So we don't know if that's true. So let's just do this. Let's drop the duplicated data in our dataset. So dataset drop duplicated. In here, we're going to see to write in place equals true. what that means. So it doesn't really change anything in terms of like the order of our data. So yeah. Mm-hmm. Oh, drop duplicates. Yep, it's done, I guess. So let's start pre-processing our data, right? So if you look into the CSV, there is some like this, some value in our dataset that just says 0. This is not logical, obviously, because every human have a minimal. There is no such thing as 0 insulin or 0 skin thickness. Like this, this person doesn't have skin or something, like, yeah. So we need to change this using the mean or the average of this data set. We're going to replace these zeros with the average of this data set. So to do that, we're going to create a list of the name of the column that we have. So let's say 0 uh, accepted glucose. We have that, I believe. Oh, blood pressure, skin thickness. Okay, blood pressure, skin thickness, then insulin, BMI, insulin, BMI, diabetes per degree function. Okay, diabetes. Ah, is that how you spell? Oh, no, no, no. Degree function. Okay. Okay, I think that's all. A or H. Should we put H there? Let's just put H there. H. Okay. Now we need to count the 0. So yeah. Let's create a for loop for column in 0 not accepted. So data set column equals data set column replace 0 to 9. I know this is a very ineffective way to replace the 0, but let's just get through it because it shows you how to process. So now we're replacing the 0 with nan or non-type or none, pretty much. So yeah. Now let's count the mean of the average of the column, right? So mean, yeah. We're going to use integer, cast this to integer. So keep equals true. So we are going to count the mean for every column that we have in 0 now. That's accepted here, but we are skipping the nan or the non value. So yeah. Now let's replace the non value with our mean. Mean, yeah. So column and set dot replace. Okay. Okay, let's check if this work. Great. Module number is not attribute name. Oh, typo. Okay. Yep. Now, as you can see, the zeros and the zeros have been replaced with the average in this data set. So there is no zeros, and we can process the data set for our single layer perceptron. Let's create a new column, and now we need to split the data set into X and Y. So X is these features, right? This is the symptoms, no, not the symptoms, the factors of, like, if one is diagnosed with diabetes, right? So these are the cause and this is the outcome. So the X is the cause here, while the outcome is the Y. So let's split it like this. There is a few different, but I like to do it this way. So log in here, I'm going to be taking all of them except the last column, which is the outcome, right? So all of them except this one. So from the start, except this. So the finish line is this, so it's not going to be uh, included in the X dot values because I don't need this label, the feature label. So yeah, I just need the value. And for Y data set, I log again everything, but only this, right? Only this column that's going to be taken in the Y. Let's see. And Y dot head. Yep, this is the X, this is the Y. Okay. Now we need to scale the data, the X that we had here, so we can process it further. Okay, we're going to use min-max scaler, so I'm going to name it MMS min-max scaler. And to actually scale the data, we are going to replace the current X value with the fit transform, okay, X. So we are going to replace the current X value, this value, with the transform value, with the scaled value, right? Okay, we can see the X. This, let's see. Okay, it's working. Okay, now we need to split the X and Y into train and test data. So X train, X test, Y train, Y test. We're going to call the train test split library. Now In train test split, this method, we need to pass the x, y, random state. You can put however you want. I'll just put 0 because it's already going to be random anyway. So yeah. And then we're going to define the test size. What this means is we're going to use 20% of the dataset as our test data, while the 80% will be our training data. Okay, let's run this real quick. It's done. Okay, cool. Now we're going to actually be making the single layer perceptron. So, like I've said in the, now we're going to actually code the single layer perceptron. So we need to define a few variable first. So the first variable is the number of features. Let's see how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 features, so let's just say 8. And we have to define the learning rate. We're going to need this when we are updating the weight. Sorry. So let's put 0.1. We're going to define epoch. Epoch is going to be the amount of time of iteration that we are going to do in the training data. So let's say for now, let's just say 300. And since we are going to use an activation function, and for this particular example, I will use a binary step. So threshold, this will be our threshold because we are going to use binary step. I'm going to say 0.5. And now we need to define the initial weight, right? The initial weight, let's say, let's use zeros. So let's just use 0 for the first time since we are going to update it anyways. So the data type will be float 32. Okay, great. Okay, now let's run this. See if there's any error. Okay, no. Okay, cool. Now we need to actually iterate through our training data, right? So let's create a for loop. Epic. Okay. Here, we are going to process the training data and we are going to use some mathematical stuff, right? So 1 equals np dot dot. So np dot dot is used to multiply two variables, right? So the first we need to pass is the x train, comma, weight. So np dot, it means we are multiplying x train with weight. Okay. And now we need to define the activation function. So let's do this. We're going to create a list. We're going to see if the value of the y1 is greater or equals to threshold, then it will return 1 or true. And next is the opposite. If it's less than threshold, then it will be equals to 0 or not true or false. Sorry. And next, we need to count the error because we are going to update the weight using the error learning rate. So error y score train minus y1. This is the basic way to count the error. So the y train is what we are going to depend on when we are validating the training data, while the y1 is this value. Okay, now we need to create delta weight or temporary weight learning rate, and again we're going to use np dot. Now we need to transpose because of the shape of our x train, right? Okay, and now we're actually updating our weight with a new weight, this. So this means that weight equals, oh, you know what, let's do this. So this is the same as this. It's the same, it's just a little bit simpler. Okay, let's print some stuff just so we can see some output. Epic that I, okay, error, and wait, wait, okay, run this. Ooh. No error, okay, cool. So let's see how our machine performing. So let's create a confusion matrix first. Why is there two? Confusion matrix y train y1. Let's print the confusion matrix first. Oh, confusion matrix / and cm2. Yeah. And then let's print the accuracy too. Accuracy y train y1. Okay. Let's see. Yeah, it's all right, guess. You know what? Let's just test this machine. I know the accuracy is not that good, but let's just test this. Let's just go on. So we need to create another loop for iterating through our test data. We're going to use len, so it's going to iterate however many our test data is, because we are going to get the length of our test dataset. So let's say y2, it's the same thing basically. Forgot n w y2 threshold is probably 0. Okay, let's see the oh, let's see the y2 first. Hmm. Yeah, I'm not sure if that's correct, but let's do the same thing with this. Huh. Just do y test to two. Let's see. Oh, it's worse. Okay. If you have a low accuracy like me, so what we can do is we change the learning rate and epoch here. So let's use 0.01 and the epoch is 500. Do this again, run this again. Okay, run this again, run this again, run this again. It's a little bit better, but let's do 0.001. Let's just have fun right now, right? 1000. Okay, let's see. Okay, run this again, run this again, run this again. Ooh, we got 80%. Okay, cool. So this concludes my example of single layer perceptron. So thank you for watching, and if you like this video, press the like button, and if you're coming back, I mean, you should coming back. I have other videos, not much, but I have other videos too, so subscribe to my channel. Thank you for watching. Have a good day.